Hello and welcome. As a reminder, all attendees are in listen-only mode. You can type your questions on the chat section. Today's webinar, XW Pro Multi-Unit Design, presented by Eric Bentsen. He is an electrical engineer and a senior application engineer with Schneider Electric Solar, with over 14 years of experience.
Thank you, Sandra. I also want to thank all of those listening in from wherever you are, and I hope you're staying safe and healthy, making the most of this time working from home, if that applies to you. Today, we're going to be looking at multi-unit design. So the XW has actually been around for over a decade. It started with the XW legacy model, which was released in 2006. Pure sine wave inverter charger, split phase, has always had a separate grid input from generator input. They have different functions associated with them. 60 amp transfer relay built in, and seamless, virtually seamless transfer time. Then in 2014, we came out with the XW Plus, which added lithium-ion support and multi-unit support for three-phase multi-clusters up to 76.5 kW. We also supported AC coupling with the XW Plus model. Fast forward to today, we now have the XW Pro, which was released in Q1 of last year. It is Rule 21 compliant. We also are HECO certified as well as PREPA certified for Puerto Rico. And the Pro is compatible with the new Conext Gateway monitoring device and our new cloud server Insight 2, which actually allows settings access over the internet. So that's a huge feature that customers have been asking for years now. And of course, we're compatible with the other ZAN bus devices, such as the solar charge controllers, the MPPT 60, the MPPT 80 in particular, and then we have other accessories as well, such as AGS, battery monitor, system control panel. So strap in, let's get started. XW Pro isn't simply improving an outdated concept. It's a proven design with up-to-date functions and features. Part of the reason we have literally thousands of XW legacy models as well as Plus models in the field as we speak is because it is designed for longevity. Dust can possess conductive properties, and an accumulation of dust on electronic components can limit their ability to dissipate heat. Dust can also accumulate on fan blades, reducing airflow CFM. It should be noted the XW Pro does not draw air across the electronic components, but it draws air through a completely isolated compartment. XW has always been the heavyweight when it comes to robust surge capability. Compared to transformerless high-frequency designs, which claim up to 2 times surge, but for a much shorter duration. Other low-frequency inverters that use EI transformers are not as efficient as toroidal transformers, have more leakage inductance, and radiate more noise. The XW Pro platform is scalable up to 4 units in single phase for combined power output when inverting, charging, and selling. Note the AC sync cable and ZAN bus cable must be daisy-chained to all units in the system with only one master assigned and each with a different device number. Remember the acronym MSDXS. I use My Simple Demos Extra Special. That works for me. You may choose to use something else, but if I had to think of any one thing that generated more calls to support, it would be F66 or F69, which are multi-unit configuration faults. The XW platform has offered years of proven reliability in the field. The purpose of this training is to allow the exceptional installer to maximize customer satisfaction by adherence to specific design principles. The challenge for multi-unit systems is and has always been premature wear to the AC transfer relay when switching large AC loads. This content applies to the current product family of Conext XW Plus as well as Conext XW Pro. The applications will be AC coupling, DC coupling, on-grid, and off-grid. When a multi-unit system qualifies or transfers an external source of AC, the input and the output terminals are common. Welded relay faults can occur when the load is excessive or if there is a loop from input to output. More than 100 amps will usually weld the relay closed. The reason for this is that they don't all close their respective internal relays at the same moment in time. It may take up to a half a second between when the first transfer relay closes and when the last one closes. So this differential causes the first relay that closes to have total current across it. If the relay is welded, the fault may clear should the relay become unstuck. However, this means there is a problem that must be addressed. A loop from input to output usually occurs when the customer fails to have a bypass interlock in place or just a miswire. Sometimes a welded relay can be unstuck by tapping on the plastic cover with the back of a screwdriver handle. Historically, when welded relay faults occurred in the past, they were covered under warranty in many cases. These were evaluated in Elkhart, Indiana, and oftentimes had no fault found because the relay had become unstuck during transit. As of late, tech support typically will reject a warranty claim for welded relay issues. On the screen here, you can see 3 inverters represented, each with their inputs and outputs labeled. And so the internal relays are also represented. On the left, you see the different welded relay fault codes, and it tells you exactly which relay is welded. On the right, will identify the locations of those relays on the AC board itself. A single inverter system will have a bypass interlock T-bar that ships with the PDP and with the mini PDP. You can see the square D part number up top there, Q02 DTI. This interlock prevents the bypass breaker and the load breaker from being energized at the same time. A bypass interlock plate ships with the 120-240 breaker kit, which is part number 865-1215-01 for dual inverter systems. There is no bypass interlock plate for a triple inverter system. You can see that it is necessary to turn off the inverter's output breakers before you can slide the plate over to energize the bypass breakers. It is possible to install an automatic transfer switch to solve the pass-through limitation for a multi-unit system. Sometimes called a whole house transfer switch, these allow the grid to supply the load directly, typically the entire main service panel, while simultaneously supplying the input of the XW Pro. This allows for selling to reduce grid consumption or for charging when needed. When the grid goes down, the transfer switch redirects the loads to the output side of the XW Plus system. Today, we're going to be focusing in on 2 different models of transfer switches, both offered by ASCO. Certainly, there are other automatic transfer switches on the market that you could consider, but for the purposes of today's training, we're going to focus in on these 2. If a load assessment reveals the switched current will not be detrimental to the transfer relays, then a manual bypass switch is recommended since there is no bypass interlock plate for a triple inverter system. Here is the system in normal operation. And here is the system switched to bypass. A single XW Pro system can supply 28 amps of continuous current. A dual system can supply 56 amps and a triple can supply 84 amps. Single and dual systems do not require an external transfer switch. However, triple inverter systems may require an external transfer switch. The designer must consider the maximum surge requirements of any motor loads. A single-phase motor can draw up to 7 times its continuous rating for startup. If a motor surging at more than 100 amps happens to start at the same instant the transfer relay closes, then a welded relay may result. Consider a system that is shut down due to low battery and the customer starts a generator. If there are many motor loads, for example, refrigerators, freezers, air conditioners, well pumps, etc., then all these loads may be ready to start the instant the generator is transferred through by the XW system. This has happened and did result in a welded relay. Always consider the likelihood of such an event in your design and plan around it. Designing a system that can invert more power than pass through is not a good practice. Utilizing a whole house transfer switch will allow the cell power to offset grid demand and then switch the load to the output side of the inverter in a grid outage. Load shave and grid support do not work when using an external transfer switch. Happily, we are now compatible with the watt node meter offered by Continental Control Systems for zero export on XW Pro. So this will utilize an upstream CT that is placed between the meter and your feeder for the automatic transfer switch, and it will limit the cell power to zero out any power so it doesn't get pushed back to the grid. Here is a system where you can see that the load is being supplied by the grid and it's also supplying the input side of the XW system. And here we see the loss of grid shifts all the load to the output side of the XW Pro system. Using the grid as backup can be used as an option for customers who live in areas where selling is prohibited. This can also be the purest form of self-consumption, and if the system is designed properly, connection to the grid will be seldom. Here you can see that the ATS is being driven by the aux port, and connection to the grid would only occur if the batteries get low. The ASCO Series 185 is the most cost-effective option that ASCO offers for automatic transfer switch. It has an 11-second delay transferring to backup and then a 5-minute delay transferring back to utility. However, a dry relay contact can be used to drive the auto transfer switch to the primary or the secondary position with zero delay. If you remember our previous slide when we were using the grid as a backup, the alternate source can be the XW Pro system because external relay is normally open, meaning the XW Pro system is the normal mode of operation. The aux port would trigger active high once the low battery condition is met to close the external relay. This will cause transfer to the grid with zero delay because if you look at the chart there, we've got dip switch S3 position 1 enabled. So what that does is it bypasses the utility time delay to zero. Once connection to the grid is made, the loads will be supported by the grid until the batteries are charged to whatever battery condition the programmer deems appropriate, either voltage or state of charge. If you're using our battery monitor, you can partially charge the battery to give the solar chance to pick up, so you don't need to leave it connected until the batteries are fully charged. The aux port is completely programmable. Once the desired battery level is reached, the aux port will de-energize, allowing the relay contact to open, and connection is made to the alternate source, which is the XW Pro system. Keep in mind this only works with DC coupled systems. There have been cases where two external sources of AC had to be transferred with large loads. In this case, you can use two automatic transfer switches. If we look at the functionality of the Series 185 transfer switch, we can see that If this was a 3 or a 4 XW system, the transfer relays for AC1 and AC2 would be protected. To implement this type of scenario, the utility input can use the alternate side of the auto transfer switch with the utility delay bypass to provide instant switching to backup. Since the remote test terminals TB71, TB72 are always open, a utility failure is always simulated, so the alternate would always be supplying power, except if the alternate fails, in this case utility, and then the load transfers to the inverters. If the batteries get low, the aux port can be used to open the normally closed connection across TB71, TB72. In this scenario, the Series 185 auto transfer switch will control the generator. Once the desired charge is reached, the aux port will deactivate and close the relay, causing the load to be transferred to the inverter with zero delay, provided S3 position 1 dip switch is off, which means the transfer bypass to the utility delay is disabled. Generator will continue to run for 2 minutes to cool down. Now, the Series 300 ASCO transfer switch offers greater flexibility when specific delays are required, such as longer generator warm-up times for colder environments. It is a bit more expensive. As far as the adjustability, transferring to emergency can be set to 0. Retransferring to the normal position can be set as low as 1 second. So you have a complete range of programmability with the Series 300 transfer switch, and it does cost about $600 more than the Series 185. The ASCO Series 300 has the same external control functions as the Series 185, but adds one more called the inhibit transfer to emergency function. Of course, when grid support and/or load shave functions are desired in a multi-unit system, these functions are available if it's possible to split up the loads. Here you see a picture of a system in Massachusetts where they have one power distribution panel dedicated to 2 inverters and then a second power distribution panel dedicated to the third inverter. This will allow you to eliminate external switching and have full functionality of the platform. When it comes to residential solar, one size does not fit all. Some customers require larger inverter systems because their AC loads require it, but maybe they want a smaller battery bank. Maybe they need a very large battery bank. Maybe they have a small roof space they can't accommodate very much solar, or maybe they have quite a bit of roof space or even a ground mount array. So systems can vary significantly in their size according to the application. The XW platform provides a myriad of configurations, features, and functions that may apply to any number of use cases. Third-party products such as the Watt node meter and the ASCO transfer switches can be used to enhance the capabilities of the system and provide protection for the internal relays.
Hey, Eric, that was great. I have a question for you here. When do you decide to go with a ATS?
Well, that is probably the most relevant question right up front. You'll note that the multi-cluster design guide provides the 60 amp limitation across the board, but also applies that limitation to multi-unit systems. And it also applies the 80% rule. So, if you're putting multiple relays in parallel, then you can still apply the 80% rule. But for example, 2 breakers would give you 96 amps, 2 60 amp breakers and 3 60 amp breakers would give you 144 amps if we apply the 80% rule. But we still have to observe the 60 amp limitation of the relay. we always want to make sure that we are doing a proper load assessment and considering our surge loads to make sure that we're not going to get into a situation where we're causing premature relay wear or even welding them shut.
Can we talk about AC coupling limits?
Yeah, the same principle applies when we're AC coupling with an external transfer switch, in that your power typically when you're AC coupling and connected to the grid is supplying the main load panel. If there's anything left over, it's passing right to the grid. If the outage occurs, it transfers all of the load to the output side of the XW system, and then you're limited by the continuous wattage rating of the XW system. So you don't want to push more PV power than your XW system is rated at, and that should be temperature compensated as well. It won't hurt the XW system, but it will cause an overload condition that would require you to manually reset the system, and that wouldn't be considered a good design.
What about just 2 XW Plus system to sell 54 amps?
That's fine. No problem. You don't need an external transfer switch.
Here's another really good one, Eric, timely as well. We had a problem of oscillation of power in multi-unit arrangement split phase. Is there something to consider to avoid oscillation of power for each unit?
Oh, that's a good one. So first and foremost, always have the latest and greatest firmware. And then secondly, if you're still having issues, you can calibrate your output voltages to be closer to each other. They should be within a volt or two from the factory, but they may need to be calibrated a little bit closer. But I would say that with the latest firmware, you should not have to deal with any of that.
Let me jump to another question, Eric. How does the ATS distribute loads to all inverters equally?
The ATS is a single node, right? So it's able to pass, I believe ASCO has 2, 3, even 400 amp transfer switches. It's able to pass that single line directly through to your panel. And then if you so choose, you can also energize the input side of the XW system and then export to offset the load that's being drawn from the grid. And then and only then, if the grid goes down, do we transfer all of that load to the output side of the inverter. So we're not doing any switching of load through the inverter system, and that's what's protecting the internal transfer relays.
For an off-grid system, would this concept regarding the relay applies to the generator or just in regards to switching from the grid?
Oh, it applies to any external source of AC, generator or grid. That's why we had the diagram that I showed you that implemented 2 automatic transfer switches.
All right, those were fantastic questions, guys. Thank you, everybody. This presentation, it's being recorded and it will be posted Schneider Electric Solar YouTube channel. Usually it's in a couple of days that it gets updated. Also want to promote next week. This is our series of webinars, which we're doing every Wednesday. And next week, we're going to be talking about our rapid shutdown solution. Our speaker next week will be Jason Andrade. So thank you again, everybody, for joining us, taking the time, and I hope to see you on next week's webinar.